Hello everyone, myself Nikita Vagasya, and today we discuss about the recurrence relation using the range transformation. So first of all, what is a recurrence in algorithm? When an algorithm contains a recursive call to itself, its running time can often be described by a recurrence. In short, a recurrence is an equation or inequality that describes a function in terms of its value on smaller inputs. Next one is a difference method to solve the recurrence relation equation. So first is a homogeneous recurrence, second one is a inhomogeneous recurrence, third one is a change of variable, and fourth one is a range transformation. First one is a homogeneous recurrence. Linear homogeneous recurrence relation with constant coefficient form like a0tn plus a1tn minus 1 plus up to ak(tn minus k) equal to 0. Here a0, a1 up to ak is some constant value. In homogeneous recurrence relation, a right hand side part should be is equal to 0. Next one is a inhomogeneous recurrence relation. So inhomogeneous recurrence relation form a0tn plus a1tn minus 1 up to ak(tn minus k) equal to b raised to n p of n. Here I is a some value between 0 to k range. B is a constant value and p of n is a polynomial in n of degree d. So in inhomogeneous recurrence relation, a right hand side part is should not equal to 0. It contains some value, constant value like b of n into p of n. Third one is a change of variable. In this, sometimes possible to solve a more complicated recurrence relation by making a change of variable. So let's take one example. T of n equal to 3 into T of n by 2 plus n. So that in this T of n is for the form of general recurrence term. Like we assume that n is equal to 2 raised to I. So T of n equal to T of 2 raised to I. Then take capital T of 2 raised to I equal to small ti. So that ti for the term a new recurrence relation obtained from the first by a change of variable. Fourth one is a range transformation. A fundamental recurrence can be defined as follows. So this equation is defined by the fundamental recurrence. S of n equal to S of n minus 1 plus d of n. Here we take S of n equal to 0 and d of n is a deriving function. Consider this equation is a fundamental recurrence relation because it has some solution. Like we assume that S of n equal to sigma I equal to 1 to n d of I. So for instance, we take d of n equal to n. So our equation S of n equal to sigma I equal to 1 to n. And so we formula for this equation is n into n plus 1 divided by 2. In this, to reduce the arbitrary recurrence to the fundamental recurrence, that time we used two methods. First one is a range transformation and second one is a domain transformation. Let me briefly describe the range transformation. What is the range transformation? So recurrence relation is a form of the R of n equal to a into R n minus 1 plus d of n. Divide this equation by the a raised to n. So we get like R of n divided by a of n equal to a into R of n minus 1 divided by a raised to n plus d of n divided by a raised to n. So we take R of n divided by a raised to n equal to S of n. Put this value into this equation and we get the final equation like S of n equal to S of n minus 1 plus d of n divided by a of n. Then take s of n minus 1 equal to r of r0. So we get s of n equal to r0 plus sigma I equal to 1 to n d of I divided by a raised to I. And consequently we get the r of n equal to a raised to n into r of 0 plus sigma I equal to 1 to n d of I into a raised to n minus 1. So that the above approach is called a range transformation. Since S of n is a transformation of the range of R of n, here domain is the same. Here we take one example to solve the recurrence relation using the range transformation. So T of n equal to 1/3 when n equal to 1. Otherwise, take T of n equal to n into t square of n by 2. So take the equation T of n equal to n into t square n by 2. Here we assume n is equal to 2 raised to I. So convert into this equation into log form. So we get I equal to log n base 2. So T of n equal to T of 2 raised to I, and we put this 2 raised to I into this equation, we get T of 2 raised to I equal to 2 raised to I into t square of 2 raised to I divided by 2. Then get the equation 2 raised to I into t square of 2 raised to I minus 1. Take t of 2 raised to I equal to small ti. So we get the equation t of I is equal to 2 raised to I into t square I minus 1. Here t of 2 raised to I minus 1, that time we put t of I minus 1. So that here put the t square I minus 1. I call this equation is first. Equation 1 is not a linear equation because 2 raised to I is a coefficient but not in a constant form. So that this equation is a not linear homogeneous equation. Then convert this equation into log form. So take both hand side log and we get the equation log ti equal to I into log 2 base 2 plus 2 into log ti minus 1. Again we assume log ti is equal to ui. So convert this equation in the form of ui and we get the new equation ui is equal to I plus 2 into ui minus 1. Here log 2 base 2 its value is equal to 1. So I into 1 is equal to I. Then ui minus 2 into ui minus 1 equal to I. Call this equation is a second. Then convert this equation into homogeneous equation and find the correct disk root. Using the substitution method, we define the root of this equation. So write the equation ui minus 2 ui minus 1 equal to I. Then subtract by 1, we get the ui minus 1 minus 2 ui minus 2 equal to I minus 1. Again subtract I by 1, So we get u I minus 2 minus 2 into u I minus 3 is equal to I minus 2. Then convert these three equations into homogeneous equation. So we right hand side part will be make us 0. So in this a second equation we multiply by minus 2 and sum of these equations we get the right hand side part should be 0. So ui minus 2 ui minus 1 equal to I. This equation is as it is. Multiply this equation by 2 minus 2. So we get minus 2 into ui minus 1 minus minus plus 4 ui minus 2 is equal to minus 2 into I minus 1. And third equation is as it is ui minus 2 minus 2 ui minus 3 is equal to I minus 2. The addition of these three equations and we get the final equation like ui minus minus 2 is minus 4 ui minus 1 plus 4 plus 1 is equal to 5 ui minus 2 minus 2 ui minus 3 is equal to right hand side we take the addition, so we get I minus minus 2I minus minus is plus 2I plus I minus 2. So cancel minus 2I and I plus I term and 2 minus 2. So we get the right hand side should be 0. So this equation is called as a homogeneous equation and convert this equation into correct this equation and we get the root. So convert this equation into correct this equation and we get x cubed minus 4x squared plus 5x minus 2 is equal to 0. Call this equation is 4. Here we assume to take x equal to 1 and put into the equation number 4. So we get 1 minus 4 plus 5 minus 2 equal to 0. So we get the right hand side equal to 0 when we put the x equal to 1 into this equation. So we find the second root. So use this method to find the second root. Like we put 1 minus 4 plus 5 minus 2. That time we assume x equal to 1 is one root. And sum this 1 plus 0. So we get the 1. Then again multiply these two numbers and write the answer into here. So we get like 1 into 1 is equal to 1 and sum these two, so get the minus 4 plus 1 is equal to minus 3. Then again multiply these two numbers, minus 3 into 1 is equal to minus 3. Then sum these two numbers and we get the 2. Then again multiply 2 into 1 is equal to 2. So minus 2 plus 2 equal to 0. So final we get the 0. So x equal to 1 is a solution of this equation. Then write the equation x cubed minus 4x squared plus 5x minus 2 equal to 0. Then we find the one root is x minus 1. So write here in the multiplication form. So like x minus 1 into x squared minus 3x plus 2 equal to 0. Here multiply this number by x squared, x and x raised to 0. So get this equation. Again solve this equation and we get the 2 root x minus 2 and x minus 1. So here we get the 3 root value r1 equal to 1, r2 equal to 1 and r3 equal to 2. Then we write root equation is ui equal to c1 r1 raised to I plus I into C2 R2 raised to I plus C3 R3 raised to I. Here n is a not, we cancel this and take I value. So we get the C1, put R1 is equal to 1 into this equation. So we get C1 into 1 raised to I plus I into C2, put R2 equal to 1, so 1 raised to I plus C3 R3 raised to I, put the R3 equal to 2. So we get the final equation is ui equal to C1 plus I into C2 plus C3 into 2 raised to I. Give the number equation 5. Then put ui value in equation number 2. Here equation number 2 is ui minus 2 into ui minus 1 equal to I. Put ui value into this equation and ui minus 1 value also in this equation. So we get the final equation value. So ui is equal to, we put C1 plus I into C2 plus 2 raised to I into C3 minus 2 raised into ui minus 1. So here we only changes I minus 1 and here we also change I minus 1. So we get minus 2 into C1 plus I minus 1 into C2 plus 2 raised to I minus 1 into C3 equal to I. Solve these terms and we get the C1 plus I into C2 plus 2 raised to I into C3 minus multiply here 2 into this whole term and we get 2C1 minus 2 into I C2 plus minus minus plus 2 into C2, then minus 2 into 2 raised to I minus 1. So we get the minus 2 raised to I into C3. Then cancel these two terms. So we get the final equation like C1 minus 2C1 is equal to minus C1 plus I into C2 minus 2I C2. So we get the minus I C2 plus 2C2 is equal to I. Then we write in the form like I is equal to 2C2 minus I C2 minus C1. Then get the value C1, C2. So we assume I equal to 0. Then put I equal to 0 into this equation and we get the C1 and C2 value. So when put I equal to 0, we get 0 is equal to 2C2 minus 0 into C2 minus C1. So we get the C1 is equal to 2C2. Then again we take I is equal to 1 and solve this equation like 1 is equal to 2 into C2 minus 1 into C2 minus C1. So we get the 1 is equal to C2 minus C1. Then put this C1 is equal to 2C2 into this equation and we get the C2 values. So 1 is equal to C2 minus 2C1. Here we put C1 is equal to 2C2. So we get the C2 is equal to minus 1. Then put this C2 is equal to minus 1 into the equation C1 is equal to 2C2. So we get the C1 value is equal to minus 2. Then put this C1 and C2 value into the equation number 5. Our equation number 5 is UI is equal to C1 plus I into C2 plus 2 raised to I into C3. So put C1 and C2 value. So UI is equal to C1 is minus 2 plus I. C2 is minus 1. So minus 1 plus 2 raised to I into C3. So we get UI is equal to minus 2 minus I plus 2 raised to I into C3. So we write this new form UI is equal to 2 raised to I into C3 minus I minus 2. We know that UI is equal to log Ti. So we also write Ti is equal to 2 raised to UI form. Then put UI value into this term. We get the 2 raised to I into C3 minus I minus 2. Simply we put this UI value into this UI and we get this Ti value. Note that I is equal to log n. So that n is equal to 2 raised to I. Our equation we take T of n is equal to T of I. Put I is equal to log n into this term. So we get the T of log n. So we get the 2 raised to n into C3 minus log n minus 2. Here we put 2 raised to I equal to n and I is equal to log n. So we get the final term is 2 raised to n into C3 minus log n minus 2. Then also we write in new form 2 raised to n into C3 minus log n plus 2. So we also write 2 raised to n into C3 into 2 raised to minus log n plus 2. Then this term also write here. So we get 2 raised to n into C3 divided by 2 raised to log 2 n plus 2. So we also write like 2 raised to n into C3 upon 2 raised to log n base 2 into 2 raised to 2. Here 2 raised to 2 is equal to 4. So 2 raised to n into C3 divided by n into 4. Here we put 2 raised to log n base 2 is equal to n. So we replace this term by n and we get the final value 2 raised to n into C3 divided by 4n. So that we get the T of n is equal to 2 raised to n into C3 divided by 4n. In equation n is equal to 1, that time the value of Tn is equal to 1/3. So we put n is equal to 1, the value of this equation is equal to 1/3. So T of n is equal to 2 raised to n into C3 divided by 4n. Then put n equal to 1. So here we write 1 by 3 is equal to 2 raised to C3 divided by 4. Here we put n is equal to 1. So 1 into C3 is equal to 1. So we get the 2 raised to C3 is equal to 4 by 3. So, we get the value of C3 is equal to log 4 by 3 base 2. Put this C3 value into the equation T of n. So, our T of n equation is equal to 2 raised to n into C3 divided by 4n. Then put C3 is equal to log 4 by 3 base 2. So, we get 2 raised to n into log 4 by 3 base 2 divided by 4n. We also write this form into this is 2 raised to log 2 4 by 3 whole raised to n divided by 4n. So here we also write this like 4 by 3 whole raised to n. So we get the T of n is equal to 4 by 3 whole raised to n divided by 4n. Then also write T of n is equal to 4 raised to n divided by 3 raised to n into 4n. So we get the final solution of our equation is T of n is equal to 4 raised to n divided by 3 raised to n into 4n. Thank you.